Welcome everybody to the next in our series of webinars put on here by Precision Roll Grinders. Today we're going to be talking about precision calendar roll grinds and how those might help drive paper machine performance. We try to keep these to about 20 minutes in length. So what I've done is everybody is muted at this time. And at the end of the session here, we'll unmute everybody. If anybody has any questions, feel free to ask them then. There is also a function where you can raise your hand that will let me know that you may have a question, or there's a chat function as well that can be used for questions. And so we'll go ahead and get started here. When we talk about calendar rolls, one of the topics or one of the issues that comes up when we're talking to paper makers all the time is I really don't need the level of precision that you guys are offering me on my calendar. And in short, as we dig deeper into the way paper machines are performing in this day and age, the answer to that question is yes, you do. And some of the properties of your paper that are directly impacted by the calendar roll performance are the strength of the sheet, which is obviously very important in packaging grades, but it's also any continuous web-based process, whether it be a printing operation or a converting operation. The consistency of the strength of that sheet is extremely important. Also, the smoothness is directly impacted by your calendar rolls. And your customers and end users demand a world-class printing surface if you're making a printing grade, or even if you're making a lot of brown grades. A lot of those grades are being printed as well, so smoothness is very important. Good caliper control is another one that's directly impacted by calendar roll performance. And we'll talk about that a little bit more, but basically that's what helps us build a really good reel, reduces losses at the reel spool, and also improves the winder runnability. And also longer run life, which obviously is important in this demanding maintenance age that we live in. Maintenance staffs are being reduced. The amount of available maintenance hours are being reduced. So the longer that we can keep rolls in the machine, the less time we've got to worry about calendar rolls during an outage. And lastly, the types of fixers that machines nowadays are using to help overcome issues with calendar rolls, such as cal coils or re-wetting or steam boxes or whatever it may be, we can also improve those areas by increasing the performance in the calendar rolls. When we look at sheet variability, one of the most prevalent issues that we see is barring. And barring is a variation in the roll surface that's usually seen in the machine direction of the roll. They are horizontal high and low areas that directly impact sheet performance. One of the ways that we can illustrate barring in the field is with a simple lead test, which any of the account managers for Precision Roll Grinders can set up and do a lead test during an outage on your machine. We'd be happy to do that. Another method of showing barring is by using a simple nip impression paper. This is your typical carbon transfer nip impression paper. And what we've done here on this picture on the right is actually feed it through in the machine direction in several, in this case, 6 strips. And if you look at the picture, you can see clearly what those bars or ridges in that roll look like. Now, keep in mind that these ridges are very small in size. They can be 5 to 10 micron from peak to valley. But if you look at the graph in the center of the sheet, that very small variation in machine direction thickness can lead to very large variations in strength in your sheet. In this case, up to 20% strength variation. You can see the correlation there between the thin spots in the web and the weaker spots in the strength performance. Just to expand on that a little bit more, this is a case where we collected some data, worked with our customer to eliminate the barring that they were seeing in the machine, And because of that, a couple of things happened. The most important thing was that they were able to reduce the basis weight that they were running in the machine by 0.2 pounds. And what that allowed them to do is produce the same strength characteristic sheet with less fiber. And as you know, when you use less fiber, you also have the potential to increase the speed of the machine or reduce steam use, which is very important in the overall economics of a paper machine. And you can see here, before PRG ground the calendar rolls, the variation that this machine was seeing in machine direction caliper was 3.7 points. And after, it was reduced to 1.7 points, which is a 54% improvement. And just the fiber reduction alone was worth $500,000 to this paper machine. Another method that we have where we can measure and show barring is in the measurements that we take during our service of a roll. This is a roundness measurement that we can take in our shop. And one of the things that this shows is that this particular roll isn't extremely round, which you'll see here by that being a non-perfect circle. But the other thing that you can see in this illustration are the highs and lows. And each one of those peaks and valleys is what we would consider to be a bar. And then if you look at the after grind, you can see those bars have been removed, the out of roundness has been corrected, and this roll, when it goes back into the machine, is going to perform as well as it can. So the other point I'll make here is when you're looking at any graphical displays like this, make sure that you are paying close attention to the scale that is being used. It's easy to hide some of these problems not being removed by putting things on a larger scale where everything looks perfect. So to summarize the barring issue, barring can be measured. It can be measured with a measuring system. It can be illustrated with a nip impression or by using a lead test. And a lot of times you can see it in the way that your reel is being built. If you look at the picture on the upper right there, those ridges as the reel is being built a lot of times are due to variations in sheet thickness that happen to line up as the reel is being built. And by correcting that barring and giving a high precision world-class grind on the calendar rolls, you can see that reel of paper being built on the bottom is off the same machine as the one that's on the top line there. And you can see what a difference it made in the performance of that machine as the paper was being wound. So the next topic that's important when you're looking at calendar rolls is caliper variation. So barring was due to machine direction caliper variation, but we can also deal with a lot of problems with cross-directional caliper variation as well. And those issues can also lead to strength variations, which can cause sheet breaks or winder losses, can produce off-quality tonnage, and can reduce roll life. And all of those have a very significant economic impact on the machine's performance. In this particular case, when we looked at all those variables, it could be $200,000 a year. And another of the services that Precision can offer is to look at your particulars of your machine and help you to quantify what those losses may be in your operation. And we'll talk a little bit more about that here moving forward. Getting back to another real world example, in this particular case, again, we installed calendar rolls that were ground to a 2/10 original design specification. And by returning this mill's calendar rolls to those specifications, you can see some of the improvements that we saw. The cross-direction caliper variation was reduced from 0.6 to 0.3. The strength of the compression strength variation decreased from 3.7 to 1.7. The smoothness got a little bit better. Big one here is that their calendar's life in the machine went from 6 months, to 18 months. They were also, because of the the better profile, able to remove a lot of those Band-Aid fixes we talked about earlier. So the cal coils and the air hoses were removed. And the other important part is that their crowns were under control. And what we mean there is if you have any kind of a variable crown roll, those rolls are designed to operate within certain parameters. And if you're having to push them to the edge of their operating parameters, a lot of times you lose some of the control range. So by creating a geometry on the roll surface that is as good as possible, a lot of times we'll see those controls go right back to within the middle of that parameter and give the paper makers much more control of their process. If there's nothing else that we take from this presentation today, I hope you take this slide. This one kind of sums up what we've found is PRG's biggest advantage that we can bring to paper makers. And it's this, that if you improve the starting point, you can greatly increase the amount of time that roll can operate in the machine. So as we look at this graph, the orange line, the dotted line at the top of the graph, is the point at which, for whatever the reason may be, whether it be loss of profile, loss of caliper control, that's the point where the rolls have to be removed from service. And the yellow dotted line is that beginning point that most of the grind shops in North America provide. So let's say your starting tolerance is 8/10 thousandths of an inch, which is less than a thousandths, which most people would think, you know, that's a good starting point. That's where, you know, that's way more than I probably need. Well, if you look at it from the PRG starting tolerance, which is the blue dot on the left-hand side at the bottom of 2/10, what it allows you to do is to make paper for 12 months before you ever get to the starting point of where that competitive grind goes in the machine. And then you'll see the wear curve from 12 to 15 or 16 or 7, whatever that case, that wear curve is pretty similar. But because of that better starting point, you increase that roll life again from 6 months to much, much longer. Here's another real world example to kind of expand on that illustration a little bit more. In this case, this is a craft paper facility. They were using another roll service company, and they were lucky to get 6 months out of their calendar roll stack. Well, they decided to finally give PRG a shot at the rolls. We ground their 2 calendar rolls and installed them in the machine. And the caliper variation graph that you see on the right-hand side of this sheet is after 2 years in operation. So you can see after 24 months of running, their caliper variation was still well within their parameters for control. Based on the analysis of how that caliper degraded over time, the estimate is that these rolls are going to run for over 36 months. So again, we're talking from 6 months to 3 years in operation. And in that, you know, obviously that is less roll changes, less off quality product that's produced. And, you know, when we start talking about that type of runtime extension, we could be looking at hundreds of thousands of dollars of savings to a paper mill. And as we talk about downtime and machine time availability, another area that we're very happy to work with you on your production side, maintenance side, engineering side is, you know, most of our customers in the paper industry know exactly what an hour of their machine time is worth. So if you can reduce the number of outages that are associated with calendar rolls, or if you can reduce the time that a machine is down for calendar roll changes, then all of that additional machine availability can go right to the bottom of the line. So if your machine is worth $60,000 an hour or $200,000 an hour, that is a significant amount of machine uptime that is available. And, you know, one of the points that we'll make here is that if you were to look at the typical service cost for a set of calendar roll and compare that with other expenditures in the mill, in a lot of cases, calendar roll grinding would be almost at a capital level expense. And so we should treat it like one. We should do the research and make sure that we're getting the most return for that investment. And if you look at this case on the right-hand side of the sheet, this is a case where we were only grinding one out of the set of calendar rolls, but even in that case, we were able to greatly extend the amount of time that those rolls ran in the calendar stack. So how do we complete these studies and what does it take? Well, we have a team of application engineers that we will work with your engineering department, your production department to design and implement experiments, to do data analysis, and that data can be collected by your onboard measuring systems that are already on your machines, or it can be, we can determine that there may be some other data that we as account managers for precision roll grinders can come in and collect data. But we'll work with your technical group to collect and analyze the data. Ideally, we have data that's taken before switching to PRG services and after, so that we can analyze and put a monetary value on what those services are actually worth to your mill. And this method is given, all of the statistical rigors of a Six Sigma type project. And our goal when we design these process improvements is to establish a measurable monetary means of measurement so that we can give you data that is useful to your performance evaluation. And we realize also that while we're asking for all of this time as far as data collection and data analysis, we're also living in a world where we're doing a lot more meetings like this, where we're online or virtual. So we want you to know that just because we may not have full access to your mill and your machine, we still are willing to create and do these designs of experiments almost completely virtually if necessary. So we can work with your group. If you send us data or send us samples, we can do the collection and validation of that. And we can also do troubleshooting via pictures or videos. So just wanted to make everybody aware that that is an option as well. This page illustrates another of the tools that we have that we can work with you on. This worksheet is something that we can provide to the mill to help you establish what the particular costs of an improperly ground roll might be. The nice thing about this and other sheets that we have like this is a lot of times our customers are hesitant to share some of their critical data with us as far as costs of operation, and we understand that. So we make tools like this available to you where we highlight the cells that that you can change and plug in your actual numbers, and it will recalculate that bottom line dollars so that you as an organization can evaluate that without us necessarily seeing some of that critical data. Obviously, if you want us to work with you to develop these things, we're also more than happy to do that. So it's just one more tool that we have to help justify and show some of the improvements that can be made in the calendar section. Moving on to the next topic. So roll life and performance don't end at the roll face. So we like to include this slide just to show you what other types of services that PRG offers. And all of these services are important when evaluating rolls to determine whether you're getting the most out of the equipment that you have. And so again, all of these can have a significant impact on how the machine or the roles perform in the machine. And all of these are also services that we provide on a normal basis in all of our facilities. And part of returning the roles to the original design specifications is making sure that all these aspects are examined. And we're going to talk a little bit more about that here in a second. So the first area that we feel is as critical as the face is the journals. And that is why every roll that we receive, we disassemble and inspect the bearings, the housings, the journals, the seals, and the seal fits to make sure that all of those things are within design parameters. And measuring those things is just one part of the program. We also have the ability to fix them if there are issues. And that is just as important, if not more important. And one of the limitations in a lot of rolls that may be ground on bearings or in housings is that you never really get to see what the impact of these critical surfaces are. And so when we set up on a roll, we set up on a bearing seat and we check it versus seal fits and make sure that the bearing and the seal fits and the face are all running concentric to one another. If they're not, we have the ability to fix them. If a bearing seat is undersized, we'll inspect it, we'll determine that, and we can repair it. We can do nickel plating, we can do other coatings of some types, we can do replacement journals to make sure that we bring those back to the geometry that they are designed to operate at. And the bottom line is that these rolls, when they come back to your facility, are ready to run, and they will perform as designed or better than they were originally designed to perform. So one more time, I just wanted to illustrate this slide as we begin to wrap this up and highlight that our application engineers are ready and willing to work with your production or maintenance or engineering teams to show you possible ways that we might be able to improve your calendar roll performance and what that improved performance means to the overall profitability and runnability of your paper machine. Again, our goal is to improve your process and improve your profitability. So if you feel like there might be an area where we can help, I encourage you to reach out and contact one of our 4 facilities. All their numbers are listed there. Or you can also visit our website, which you see there at the bottom, precisionrollgrinders.com, and we would be happy to have one of our account managers get in touch and set up any next steps that might be necessary. So that pretty much concludes my portion of this the presentation. So at this time, I'm going to unmute everybody. And if there may be any questions out there, please feel free to ask them now. If not, we did have a couple questions come in on the chat function. So the first one asked, do we handle variable crown rolls? And the answer to that is yes. We rebuild conventional swim rolls, sim rolls, NIPCO rolls, pretty much any type of controlled crown, variable crown roll, we can test and rebuild completely. I see one more came in, asked, do you handle door-to-door services? The answer to that is also yes. We do have, every one of our facilities has roll transportation firms that specialize in these critical type of shipping. So we can set up pickup and delivery of rolls and handle everything from one end of the job and deliver it back to the mill when we're finished. All right, that was all of them that came in over the chat. We're at 25 minutes, so we did pretty good on timing. If we don't have any other questions out there, which I am not seeing, then I guess we will wrap things up. Again, we thank you very much for attending this afternoon. Appreciate your interest in this topic. We will make sure we keep you aware of future webinars, topics that we may be considering, and hopefully you can join us again. But if there's nothing else, I hope you have a great rest of your day and rest of the week. And again, thank you for attending today.